Okay, then. Well, first of all, welcome everybody. Thank you for being here, for attending this first session. Uh, Deep learning is like the subject I like the most of all the subjects I am fortunate enough to teach in Tec de Monterrey. And I love deep learning. I mean, I love all the version. I've been now teaching this particular class. This is going to be the third time. And also I'm teaching deep learning in undergrad for the students in the program of robotics. So I teach deep learning there. And this semester I will also start teaching deep learning for the masters in computer science, the one that is like research based. This is the masters in, they are very similar in the sense of the program. The masters in computer science is very machine learning oriented, but is the one that is full time and is like the more traditional kind of program. So yeah, this is my favorite subject. I also in the undergrad department, in the undergrad there is the specialization in AI for undergrads. I also participate in that one. So I really like it. I enjoy a lot having the opportunity of talking about deep learning. It is really challenging to teach this subject because it's the one subject that changes literally every day. Well, changes in the sense that there are new things coming out basically every day. I mean, since last year, probably since ChatGPT in 2023, even before that, it was a little bit difficult to be up with the pace of deep learning and all the models that were coming back then. But since ChatGPT, all 2023 and 24 have been really, it has been evolving at such a pace that it's difficult to follow. And what we're going to do is to cover I think the first half is going to be all the fundamentals that are going to allow us to understand, to take a paper from uh, from that is coming out now and have a good understanding of it. So you will see the program. The program, we are going to be unveiling the contents every week. This is by design. So, but in general, I mean, we are going to be covering the first 5 weeks is going to be foundations of neural networks. We are going to go behind a little bit of the math and the background that is going to allow us to understand how neural networks learn. We are also going to be covering the fundamental model, the NLP, which is probably the most traditional neural network model. And then we are going to go through convolutional neural networks, which even today, is probably the most, not probably, is, I would say, let's say arguably the most successful neural network model in terms of actual applications, since we are going to talk a little bit of the history today. But since 2012 that it became relevant again, it's not that it was invented in 2012, it had been for over 30 years back then, but in 2012, there is these developments when people start looking at the convolutional neural network. So that's going to be up to week 5. After that, we are going to have 1 week that we are going to take kind of a breathing week. We call it a reading week. That is going to be the first quiz. So that's going to be a week for you to catch up with all the material that we have and also take the quiz, right? So after that, we are going to go into the natural language processing realm, and we are going to start with some models that today probably are a little bit being phased out due to the transformer. I'm talking about recurrent neural networks. So we are going to spend a week or two in recurrent neural networks and its variations and how they were really key for the first like translator applications back in 2017. We are talking about, this is still 2017. I mean, it's not that far from now. I mean, any other subject you will be studying models that are, I don't know if you come from engineering backgrounds and you study the fast Fourier transform, which is totally relevant today. It's an algorithm from the 70s. If you do machine learning, traditional machine learning, you probably are going to be studying support vector machines, which is still not a bad algorithm or a really useful algorithm today. Tree-based algorithms like random forest. We are talking about algorithms that are from the 80s, right? And then we come to deep learning and we are talking about algorithms that are not that, I mean, they are not that new, but they became relevant like fairly recently. Like I'm talking about like recurrent neural networks in 2014. That's only, I mean, that's only like 10 years ago, which is not, but still they are being phased out, at least for natural language processing applications. So we are going to study that. And then from there, we are going to introduce the transformer, which is probably the most relevant model in the last years. The model behind, I usually say the T in ChatGPT, the transformer model. So we are going to be studying the transformer. Yeah, transformer model, we are going to study, we are going to code it, or you are going to code it like from scratch, like train the transformer and implement a translator that is going to be a really poor translator, a really bad translator, because we don't have the compute and the enough data to do it, but still the principles are the same. And then the last 2 weeks is the ones that are, depending on how we do, how we progress from up to the week number 9 and 10, my intention is to do two things, LLMs and diffusion models, which is the model behind these pretty pictures of beautiful dogs and cats. So we say, please draw an astronaut, a dog wearing an astronaut suit. So that's diffusion model. So we are going to be doing that by the end of the term. So it's a lot of information. My emphasis has always been that if we understand the basics well, the foundations well, then we can go on, because everything else is going to be basically the same principles. It's just going to be the way the transformer, even if we are talking about the newest transformers, there is this Nemotron from NVIDIA this year that is kind of cool, yeah, but this is still a transformer-based model in the 500 billion parameters. And then we have other models that are achieving 1 trillion. Still, the principle of learning is basically the same that it was for neural networks. So my point of view is that if we understand well the principles, we will have good foundations to grasp anything else. Okay, so just to talk a little bit about the grading policies and all that, you can see in Canvas. So I'm not going to spend time doing that. There's going to be some activities. There are going to be 2 midterms. There is one of the activities, the last activity, I'm just going to mention this, is going to be like a small essay that you are going to be writing in teams. And probably that tends to be the most challenging activity, even if it's the least, is the one that is not about coding, is the one that is about writing, but it's like doing, it's not like, it's actually doing a literature review. You're going to be reading some papers and then writing really concisely and briefly about the topic you select. It's kind of interesting because I mean, if you are really interested in some topic in particular, this is your opportunity to read a lot about that and actually have the pressure of a grading system to read about it. Other things, we are going to be having sessions every week. Most of the sessions, or about half of the sessions, are going to be optional. So, well, I think in general, all the sessions are optional, but still, it's really nice that you show up. So we're going to be having sessions weekly, except for week 6, the week of the midterm, but all the other weeks we're going to be having sessions. Either, in general, they are going to be like free flowing kind of sessions. It's going to be more like to have questions about doubts about the homework, something you read or heard in the news and you want to talk about. I mean, it's going to be a lot of talking. That takes me to my next point. I'm really bad at following the chat. So if you have questions, please interrupt me. Feel free to speak. I think that's the best way to do it. So if you have a question, I mean, you may raise your hand, or if you want to, if you raise your hand, then I will be able to see you, and then I will say, okay, I will try to or Yetnales is also really good at helping me with those questions. But still, if you can speak rather than typing the question, that would be better. Is going to be, because I don't, not always can I pay attention to the chat. So if you can speak is actually appreciated. Feel free to interrupt. Feel free to ask any question. The idea is to, after what I have discovered, or not discovered, but reaffirmed, is that you guys have a lot of knowledge and information to share, and it enriches a lot the class if you share what you know. So feel free to ask, feel free to share what you have read, what you have seen in the news, whatever you want to talk about that is related to deep learning. So please, just let's keep it within the artificial intelligence context, and then please feel free to ask or comment about anything.
Yeah, so there is also a question in the chat.
Okay.
Yeah, how do you keep up with all the new stuff AI related coming out?
Yeah, this is a question I have asked. So the real answer, I mean, the totally honest answer is that I'm still trying to figure out how to keep up with everything. Because really, there will be every day is going to be probably a few papers related to a new LLM or a new. Now that it's language models, everything is LLMs. I think there will be a few papers daily, and it's difficult to keep up. Something that helps a lot is blogs, like blogs from. There are very good models, like models, open models, like from Llama, and then there is some other non-open models, but still good models, like from DeepMind and Google Research, and then you have Amazon and also Microsoft. They all do usually a paper about the model, but even before the paper or together with the paper, there is a blog that tends to be like easier to digest. So I think blogs are really good is a really good way. Like blogs from these companies, like the blog about the SAM model from Meta, or the blog about Dino, and all these models from Meta is releasing really good models. I really have a lot of admiration for what Meta is doing right now. So, but in general, Google, DeepMind, they all have really good blogs about their models, and they tend to be a little bit easier and faster to read, like shorter than the papers. Apart from that, there are some really good YouTube channels. I don't know, like I haven't kept up with the new YouTube channels coming up, but there is like a traditional one would be 3-minute papers. I haven't followed it lately, but I'm assuming that it still publishes novel papers. They are not 3 minutes. They are a bit longer than 3 minutes, but still I forgot the name of the author of the channel. He does a really good job about summarizing papers. There's another channel that I forgot the name of the author. It's Yannick. I haven't been able to follow up lately, so I'm not. There might be some other channels actually that do that. So it would be a way to. It would be just good to have a look, and then probably you will find some even newer, better channels that do that. That would be my advice, and still probably not there might be other ways to do it, but it's difficult to keep up. Also, I think that if you understand, like there are some foundational papers, foundational models, and some knowledge that I would consider to be like really, really important, like that underpins everything. I think that if you understand those foundations, then and you read like some iconic, let's call them like that, iconic papers on the models coming, then whenever you are ready to apply something newer, I think you will be able to catch up really, really quicker than if you don't have this previous foundational knowledge. So I would say something that is really important is to have a very strong background in the foundations to understand what's coming, the newer models that are coming, so that whenever you want to focus in one in particular for whatever reason it is, you can focus on the implementation. Because like if you want to implement a new model, like a new LLM or so, like you want to download Llama and run it and fine tune it for your own data. I mean, you could do that without understanding, but I think that if you understand, you would have a better grasp of what's going on, and then you will have even better techniques to fine tune the models. So that would be my other advice. Be very strong in the foundations, in the understanding of what's going on behind the scenes. So, okay, so what I have prepared for today, I will share my screen. It's just a little bit of a recap of what's going on with deep learning in the last few years, I would say. But still, if you have any question and you want to ask something, and before I start, probably I will ask if there's any question or anything anyone wants to share, please do feel free. As I said, please feel free to interrupt at any point. So I hope you can see my screen now.
Yeah, also about the homework, Professor, that it's like a reminder that the homeworks have to be in English. So if there is some question, because yeah, like in last course, we have like that question. Like
Yeah, the homework, this is particularly, okay, the point of the homework is like, well, yeah, ideally the comments, many things of the homeworks, particularly at the beginning, you're going to have like a Jupyter notebook that you're going to follow. And the idea is, the key idea of the homework is that you understand the code that is provided. And to show and evaluate that you understand the code, what you are asked to do is to comment, because the code will come without comments. And one activity will be to, in all the activities, you are going to be evaluated by the comments. So the issue here is that please do the comments in English, right? So that's the key part. So that's like, yeah. I mean, and if there is any reason for, because also there might be exceptions. If for any reason you prefer to do them in Spanish, speak to us, and then we can. I think it wouldn't be an issue if for any reason, whatever the reason is, that you prefer to do them in Spanish, right? Any other language, definitely not accepted. But yeah, we can speak about it for any reason.
Good afternoon, Professor.
Hello.
I have
I
a
hear
question.
someone. Yeah.
Yeah. So, well, really happy to be here. I really look forward to the contents of this course. But I really
you.
want to know, I think that for this to work, we have to be aligned, you as a professor and we as students. So I wanted to ask, what are your expectations from us? Like at the end of the course, what is like your expectations for us to know or the abilities that we should have at that moment?
I think this is tricky, and I don't think there is a unique answer for that. I would say that, and this is something that is also difficult to evaluate for me, because it's kind of a big group. But I would say that the way you can evaluate yourself is like at the end of the course. If you take, let's say, by the end of the course, I'm sure there's going to be something like this. I can foretell the future. And by the end of the course, I'm sure that there is going to be Llama 4, or there is going to be Llama 3.5, or whatever. There is going to be a new model that is going to be something we would be talking about. Probably not in the class, but you will listen about. Okay. By the end of the course, the idea, and this is if you want to evaluate yourself, if you take the paper of this new model that is coming out, and you understand about above 50% of the paper, I wouldn't say 100%, because it's difficult to understand the paper 100%, depending on the paper, but say 50, you understand more than 50% of the paper, you're good. You're good to go. I mean, that would be the idea. I mean, that would be that when you see topics and concepts they mention throughout the paper, and you have a good understanding of in general of the paper, I would say that would be the goal. If I mean, that I would say that would be the best way to evaluate yourself, if you have obtained the most out of the course. There might be like more specific objectives, like you could say, okay, I understand how a neural network learns. That's definitely something you should know. I mean, you should know, like, depending on the data type that you are going to be analyzing and you want to solve it, you have a problem, you want to use deep learning. Okay, you should be able to identify what kind of model to use depending on the data you have, depending on the data modality. So that's something that you should be able to do. In general, you should be able to okay, I have a problem for my industry, my work, personal project. Probably I don't know exactly how to solve it, but I have a good idea of how to start solving it, addressing it, right? These are the kind of things that you probably should be able to achieve by the end of the semester. Yeah, well, not the semester, by the end of the class, because it's only 10 weeks. Yeah.
Thank you very much.
My pleasure. Thanks for the question. Yeah, but I repeat, is more something that you should be able to evaluate yourself. Like, those are kind of the things that I would expect you to do. And in general, I've noticed that it has happened. Like, I have, after the class, I have supervised some students doing the final project, and they are doing really well in deep learning wise. So it's kind of, I would say that's the expectation in general. So still, I repeat, if there is any question, please interrupt me. I'm not going to be looking at the chat now. So if there's anything you would like to ask or share, please feel free to do it. So what I want to do now is to do a little bit of the history of, I say artificial intelligence, but really is more like neural networks, deep learning, machine learning, a little bit of the perspective of how we got to this point, because I find it really, really interesting. I find the history of deep learning, artificial intelligence is kind of a really nice story. So that's how I like to start any deep learning class, to talking a little bit about this, particularly some events that I think are like really, really important, that and peculiar in a way. I mean, like if it hadn't happened, maybe, I don't know. So that's what I'm. Okay, this is me. You know my name, LinkedIn, and that you can connect with me. That's cool. So the first thing, and I'm going to be going fast in the beginning. I mean, like the concept of artificial entities capable of some intelligence, let's say quote unquote intelligence, is not new. And so these are two examples I found about like the oldest references to this kind of artificial entities that display some intelligence. One is Talos in Greek mythology, that is 700 BC, and the other one is Golem, it's about 500 to 1000 AD. And I mean, I was looking like what's the oldest reference, and this is something I found. There is something. This is still like kind of mythology, but something newer, and that is kind of an interesting reference to AI, particularly AI taking over, is the Rossum Universal Robots, which is a play from 1920. And the idea here of the play is that eventually the robots kind of rebel against their human masters. Now, the interesting part here is that the concept of the robot, and it's probably the first time that the term robot is used in this play. The difference here with robots, with the robots that we envision now, is that they were still kind of a biological creation, right? So they were still like biological entities created by humans, and in the end, or the robots rebel, right? So it's been for a while that we have this kind of concern, I would say. I don't know, it's a real concern or not. There is another one in 1927. This is Metropolis. Another, this was a film, actually, and this is another portray about robots and this kind of artificial intelligence from the 20s. So it's not even the concept of robot is not that novel. And then we have more modern concepts like the Terminator, and this particular movie, Ex Machina. This is more recent. I think this is like from 2016, 2017, something like that. Has anyone watched this movie, Ex Machina? I don't know if you can say yes. Yeah.
Yeah.
Yeah, it's a really good
Yes.
movie. It's a really good movie, particularly because it was advised by deep learning by I forgot the name, but it was a deep learning scientist that advised the movie. So it's really accurate in the terminology that they use. I mean, it's still science fiction, but the terminology they use is like really accurate. So advised by a real scientist. I'm trying to put the gallery view here. Yeah, I can see the gallery view. Also, this is just if you cannot, there's no problem. If you can turn your cameras on, that would be nice. I mean, that's always appreciated. If for any reason you can't, there's no problem. I understand as well, but so it's all right. Okay, so Ex Machina, more modern movie, really good movie. If you haven't seen it, do. I think it's interesting. So that's science fiction. So how did we get like more to the point of that we are now in terms of science, right? Like the how did we go, get to this point in deep learning? It's not new. One of the first reference to the concept of an artificial neuron is in 1943 by McCulloch and Pitts. And they presented the model of an artificial neuron that was based on an on-off state, so that it would be connecting to other neurons whenever it receives some on state, and then it would transmit another on state. So something that you will notice that particularly in these years is that the people working in deep learning, or I shouldn't say deep learning, I should say like artificial intelligence, or this concept of artificial neurons, neural networks, were either from a biological background, like neurologists or mathematicians. Basically, they were the people working on this. And in this case, McCulloch and Pitts, they were in the biological background. So they were modeling neurons in the terms of on-off states. Then we have like 1949, we have this concept, which is really important because first we have, okay, artificial neurons. And then 49, Donald Hebb presents the concept of a neuron capable, artificial neuron capable of adjusting the connections, the strength in the connections. This aligns very well with the concept of how synapses are happening and how we are receiving, how biological neurons are receiving connections from other neurons. And depending on the aggregated sum of all the incoming connections, the output is going to be propagated or not. So the neuron might have some inhibitory action or excitatory action. So that has to do with the adjustable connections. If the connections are kind of high, let's say, more likely there is going to be some excitatory action and the action potential is going to be transmitted to the next neuron. Then interestingly, in 1950, Marvin Minsky presents or builds the first neural network computer. And back then we have to think that a neural network, if it was going to be implemented, it was not going to be coded, right? It was going to be built. So he builds the first neural network. And then also he is the one who you could say killed the neural network research in the late 60s. So interestingly, in 1950, he still believed in neural networks. And then probably you have heard of this. Alan Turing in 1950 also, he presents the paper that is called Computing Machinery and Intelligence. It's the paper that presents like so many concepts. I mean, at least for the first time, he presents concepts that are really relevant to today. Of probably the most known one is the concept of the Turing test. Have you all heard about the Turing test? Has anyone heard about, or has anyone not heard about the Turing test?
Is it the Turing test the one that identifies a human apart from a computer?
Kind of, yeah. Is anyone else that wants to say something about the Turing test?
It's more, I think, the ability of the machine to think like a human.
Okay.
Yeah, it's sometimes when you try to speak with another machine and the machine try to act like a human, and
Exactly.
you, like a human, don't sense the difference between that you are talking about with a human. No, that's the
Exactly.
real Turing test.
Exactly. And it was not called the Turing test. It was called the imitation game. But then, I mean, I think it would be like kind of, I don't know. I don't know many people that name something after himself. So Alan Turing wouldn't call the paper the Turing test in his own paper, right? In the paper was called the imitation game. And that's why the name of the movie, The Imitation Game, comes from. So the name was The Imitation Game, and it was exactly that. It was like you had a human interacting, asking questions and receiving written answers, and this person didn't know if the interaction was with a human or with a computer. And if the person couldn't distinguish if the answer was coming from a person or the answer was coming from a human, then you would say that the computer was was deceiving the human, and then it wouldn't pass the imitation game. But basically, that's what the imitation game was about, and that's what became known as the Turing test. What do you think about now? Like, if we were like, in terms of the original paper as the test was presented as this imitation game, what do you think? Has it been achieved? Like is the Turing test already obsolete? I don't know or is it like if you repeat the experiment that Alan Turing did in the 50s, which is, okay, I'm going to ask a question and I'm going to receive a written answer. And if I cannot distinguish if the written answer is coming from a human or from a computer, then I would say that the computer is deceiving me. And then hence the Turing test would be passed. what about for today's standards? I mean, if you repeat that test, what do you think?
I think that the problem with the current standards, probably a machine can imitate, no, the human behavior, like when they give you some answer, no?
Yeah,
Still valid, because if I cannot distinguish if the answer comes from a human or from a computer, that means the computer has learned how to mimic. And if it is learning and improving, then I think it is artificial intelligence.
yeah, absolutely. Yeah. And the thing is that if we base the Turing test as it was, I mean, if we repeat the experiment as it was done in the 50s, in the 1950s, probably it would be, I mean, it would already been achieved, right? I mean, like the actually, if it's only by, because also remember, I mean, the Turing test was in written, so it was asking, and you will only receive the text, the text. And if you couldn't notice the difference between a human and a computer, then you would say that the human or the computer was deceiving the human. So if we repeated that,
That's
sorry.
kind of what we are looking for with the LLMs, right? That we receive, that each time we receive an answer that looks more like the one created by a human, generated by a human.
Absolutely. And sometimes we get answers that,
Actually,
yep,
I think it's more current than ever. They
okay, why?
all things. Oh, because all the GPTs and all that stuff that now we can get that kind of answers.
Yeah, I mean, and the thing is, and I agree, because I think, and I would say that most people agree that if we evaluated the Turing test with the standards that it was originally proposed, I mean, with those standards of the 1950s, I mean, it's over. I mean, I don't think we would be very good at recognizing if the answer is coming from ChatGPT or coming from a human, if it's only written. But what has happened throughout time is that as soon as a new achievement, a new milestone is achieved in AI, it's like, okay, is this a Turing test? And there is like arguments against it. And I think it's never going to be like, until we achieve like a real, if that ever happens in our lifetime, a real, this concept of artificial general intelligence or advanced artificial intelligence, whatever you want to call it, until that happens, I think people are not going to be satisfied. And the concept of the Turing test is just like, okay, it's nice to have, but I don't think is that relevance, in the sense that as new milestones are achieved, we will argue something against it. At least that's what's going on until today. Yes, so there is someone asking something. Okay. Yes, I cannot listen. I don't know if it's my problem.
No, I can either listen. No. Maybe they.
Sorry, can you hear me now, Professor?
Yes, I can.
Sorry, yeah, sorry. I was saying with this, with the testing, for example, with the latest model that OpenAI launched, like O3, there is like a lot of discussion if they achieve AGI, because that's gonna corrompt the agreement with Microsoft. So, which organism or who people or which are the groups of persons that decides which are the testing where we are testing or the models to determine if we pass the Turing test or we achieve the AGI, or how that works?
I don't think there is like I mean, there is not a group of people that say, okay, these are the authorities and these are the people who are. And if you listen to the experts, like if you listen, I mean, people who are considered the real knowledgeable people, like Geoffrey Hinton, who won the Nobel Prize this year, and then you listen to Jan LeCun, we would both agree, definitely, we will agree that they both are two of the most knowledgeable people in the world to talk about this, and they would disagree. Like Geoffrey Hinton lately would say that we are achieving to something that is way smarter than humans in some aspects. But Jan LeCun would say that autoregressive models, which is the kind of model behind the GPTs or the GPT family, are not the way to achieve, and he has arguments for that. And he would say, do not work in LLMs. I mean, I've heard him saying that. I mean, so I don't know. The answer is I don't know. I don't know. I don't know when the consensus is gonna.
Yeah, I know. It's hard. It's hard to define. Thank you.
I don't think there is like a. I think at some point, and my view, this is just a personal view, is that at some point it's gonna happen, and eventually, little by little, we are gonna say like, okay, is there no? But I don't think it's gonna be like overnight. We don't have AGI. Next day we do have it. It's gonna be happening little by little up to a point that we cannot deny it is there without us realizing that it happened. That's what I believe is gonna happen. I don't know what's the time frame for that. I mean, it might be years. I mean, some people say like Andrew Ng from the founder of Coursera, he would say it's 100 years, not less than that. So who knows? I don't know. Okay, yeah, the assembly test. It might be. I don't know. Yeah. Yeah, that's right. Yeah, if it can do that in assembly, probably it's a computer, not a human. But still, that's like the anti-Turing test, isn't it? Like can a human? Yeah, eventually it might happen. Like can a human pretend to be a computer and answer so well that we think it's a computer? Anyway, we keep going. Some of the concepts that came in this time from this paper is precisely the concept of machine learning, the concept of genetic algorithms, and reinforcement learning. They are presented, I think, for the very first time in that paper in 1950, in that paper from Alan Turing. So the question was if machines can think, and then he proposed the imitation game, right? This is a little bit more of the, and this is a test. A computer passes the test if a human interrogator, after posing some written questions, cannot tell whether the written responses come from a person or from a computer. So in that sense, I would say that this is already, we achieved that. We passed the Turing test. So, but as I said, as new milestones are achieved, like the Turing test is just like changes. It is being adjusted. So yeah. Something really important, and this is another event that I think is something that we should bear in mind when we are talking about how AI came to be. In the summer of 1966, there was this brilliant people like I have mentioned before: Marvin Minsky, John McCarthy, Claude Shannon, and Nathaniel Rochester. Particularly, you might recognize the name of Marvin Minsky. If you don't, he probably is considered the father of AI, like traditional artificial intelligence. If you come from an engineering background, like electrical engineering, you might recognize the name of Claude Shannon. Does anyone know what Claude Shannon is famous for? Any electrical engineer here? No?
The theorem of Shannon, Professor.
The Shannon theorem, exactly.
Yes, that says that you must sample a signal twice the frequency, right?
Yeah, exactly. You have to sample a signal at twice the maximum frequency contained in that sequence, and in order to be able to reconstruct a signal fully, you need to sample it at least twice the maximum frequency contained in that signal. So twice the maximum frequency contained in the signal. He's known as the father of information theory. Yeah, Claude Shannon. So probably most famous for that, not for his AI contributions, but still. So these four people, really clever people, really geniuses, they said, okay, the problem of AI is kind of, okay, making a computer. Computers are now like super powerful. I mean, it's 1956. Computers are really powerful. So we can build a computer. This guy Turing showed that they can do and solve these cryptographic messages. So if we, people like us, as clever as us, get together for a couple of months, for sure, we can solve the problem of artificial intelligence. Right? And basically that's what they proposed. They get money for that, and they organized the Dartmouth Summit in 1956. So they get together with another 10 people that are all really clever people, and they are going to solve AI in a couple of months. John McCarthy, by the way, is the one who comes with the term artificial intelligence. And it was in this summit, right? So as we all can guess, they didn't achieve their objective. And they still said, like, okay, it's gonna take probably a couple of years, but it's gonna be done soon, right? And even so, I mean, they are not like, I mean, they definitely didn't solve the problem of AI. Like, they didn't achieve that a computer actually does whatever we could think like a human. They didn't achieve that, but they did. I mean, there are some important milestones from that time. Like from those years, you can have like there is a checkers algorithm that was a significant milestone. The Lisp programming language, the functional language, sorry, the functional language called Lisp was invented back then as well by John McCarthy. There are some important milestones in that. I would say that one of the most important ones is the concept of the perceptron by Rosenblatt in 1957. The perceptron, as we will see, is the foundational artificial neural network. Is the artificial neuron, not neural network. The foundation for the artificial neural network, but is the neuron, the artificial neuron, as we know them today. Like one neuron that receives inputs, and we are multiplying the inputs by certain weights. So yeah, I'm probably going to go back to the perceptron, because it's a really remarkable concept. I mean, it's the first time that someone models an artificial neuron as really is just a linear operation that is a dot product. We have different inputs coming into the neuron. We multiply each of the inputs by a different weight. We sum all the weights, and then we get the output of the neuron. That's the perceptron presented in 1957 by Rosenblatt. And that's the foundation of neural networks even today. That's the artificial neuron that we still use today. So it's a really important concept in 1957. If I'm not wrong, I think Rosenblatt passed in the 60s, so he didn't get a chance to do a lot of research in neural networks. But he presented the concept of the perceptron, which is really, really important. The 60s is a little bit what precedes the first winter of AI. Is when, okay, people for over a decade had been promising that they can solve intelligence very soon. So it's gonna be next year, but probably, okay, next year comes and it's gonna be next year. It's probably like, yeah, probably like Elon Musk saying that fully autonomous driving cars are going to be like in 2021 or something like that, and it's still not happening. Something even probably more I would say something similar was happening. They were overpromising and under-delivering. But the difference is that they were not millionaires. They needed money from government to do the research. And government was like, okay, we've been giving you money, guys, and you're still promising things that we are not achieving. So yeah, I think we are not gonna give you more money. So not for AI. And that's one of the first winters of AI. We have been like so-called, we have had two winters in artificial intelligence, which are these periods when the governments stopped funding research in AI due to lack of results. Also, something really important that happens in 1969, and I was telling you that Minsky was the one who built the first neural network computer, but he is also the one that published the book, The Perceptrons, or Perceptrons, in 1969. This book shows that a perceptron cannot solve complex problems. In particular, it shows that a perceptron cannot solve an XOR, an exclusive OR. Like this very basic, simple logic function cannot be solved with a perceptron. And because of that, there is today is seen as is in agreement to think that there was a misunderstanding in the artificial intelligence community when they that makes them assume that, okay, if the perceptron cannot solve such a simple function, then neural networks are worthless. I mean, they are not going to work for anything. They are not going to solve the problems. So AI is worth following, neural networks are not. So don't follow neural networks. And so on top of having a winter in the AI in general, 1969 with this book, The Perceptrons, this Minsky and Papert is the other author, kind of, in a way, I wouldn't say kills, but hinders the research in neural networks in particular, which is a misunderstanding because they show that the perceptron was not capable of solving this problem. They didn't show that grouping many perceptrons, both in parallel and sequentially, which is basically a neural network, they didn't show about neural networks. The limitation was only for the perceptron, but kind of the community interpreted that or assumed that this was extended to neural networks. So not many people continue working on neural networks after this, except for the people who kept working on neural networks. So that's when the first winter came. So something to bear in mind is that the ideas and the algorithms back then, they were brilliant. The problem in part was that the computational power was very limited. Computers were not like, the general program computer was not available back then. So it was not like they could just test any idea they had, code it in Python, and then have the result. So in part, I think the problem of computation was a limitation. There was still some, I said before, the Lisp language, Lisp was still used in the 90s for problems of artificial intelligence. Even the early 2000s, people were still using Lisp. And you will find people today who loves coding in Lisp. It's a functional programming language. What was this? Oops, what happened here? Let's show. So the concept of garbage collection was also invented back then. Something that happened and actually is worth mentioning is that from the late 60s, 70s, even 80s, given that neural networks were not like that popular, the AI research that was carried out was mainly focused on using what we now call expert systems, which is these systems based on rules. And this is kind of the best depiction of the meme that probably you have seen, that AI is just if else, if else, if else, if else, if else. That's kind of an expert system. So it's based on rules when you have a group of experts in the domain of the problem you want to solve. And then you have a group of experts in computer science that are going to extract the knowledge from the expert of the domain, say medicine, and they are going to code it. And you may imagine that the amount of rules that you might need to code will grow probably really large very quickly. Very simple example, the canonical example of machine learning recognizing a cat from a dog. We could try to write a program that does it like rule-based, but eventually we are going to come to a point that we cannot just address all the differences, the possible cases. That was the limitation of expert systems. Yet, expert systems were very popular in the 80s. They were very successful. As a personal experience, I can say that when I came back from my PhD and postdoc to Mexico, my first job, I was working first job after the PhD. I was working we were doing projects, right? And one of the projects we were doing is for Sensata. You might have heard of Sensata. It's quite a really large company. They do sensors, like small sensors for cars and many devices. Yeah. Anyway, they are doing they produce one motor sensor, which is basically a very small, thin film of two metals, and then they have to make the the alloy of the two metals, and then they pass the little metal. I mean, it's a strip, like 1 inch, and they have to form the strip. By this I mean like they use like servo motors, and they are pushing and pushing in both directions, and then through a heat process, the metal gets to certain properties, so that whenever you have like, they use them in refrigerators, whenever you have like too much current and there is an increase in temperature, the metal would pop, pop, and would open. And then when it cools down, it closes back. And then if there is and this happens because if you have like a short circuit, then the temperature will rise, and then you want the metal to protect the motor. And so that saves your refrigerator, basically. And Sensata does about 95% of these protectors in all the fridges in the world. So yeah, most likely, I mean, well, what the engineers in Sensata were saying is that they do most likely our fridges, I mean, use one motor protector built in probably in the plant in Aguascalientes, or there is a mirror plant in China. So still, the process of controlling that bending of the metal to get the final characteristics of the metal so that it reacts to the appropriate temperature was done with an expert system. And I can say that that expert system was running still successfully this was 2016. So they were successful and they stayed for a long time. Nonetheless, they had some issues, and the issues were that they were kind of complex. Not anyone could code it, and also they were really bad at handling data that was not within the data, it was coded within the rules. So if by any reason you receive something that was not within the rules, the results were really poor. So still, and really expensive. Probably that was the main reason they became like not so popular anymore, but still quite successful. Probably the most famous expert system is Deep Blue. You might have heard of it. Deep Blue was this IBM system that beat Garry Kasparov in 1997. That was the first computer, AI, that was capable of beating the world champion of chess. So that was a really, really impressive remark. 1997. But still, it was a computer that was trained by a lot of computer experts in combination with grandmasters. And that was one of the complaints of Garry Kasparov at the time, was that Deep Blue was capable of studying all his games, all his matches, but Garry Kasparov didn't have access to any match of Deep Blue because there were none. So yeah. So in that sense, the information was not like equally split. I mean, there was more information about Garry Kasparov than about Deep Blue. So yeah, basically, just a summary of what we have seen so far. 43, the artificial neural networks. 57, the perceptron. 69, perceptrons, we don't like them, they don't work. Now, that kind of kills the neural network research, but still there are people who are still working in neural networks. And this is the people that we're gonna see now. Still, in the 80s, the backpropagation algorithm, which is the very same algorithm that is used to train neural networks today, like LLMs are trained using some variation of the backprop algorithm. That was not invented, it was invented in the 70s or probably prior to that, but it was in the 80s that it was used successfully to train the first neural network. That was 1986, Geoffrey Hinton, the guy that won the Nobel Prize this year. Yeah, that guy, 1986. Together with some other people, they wrote a paper that shows how you can use backprop to train successfully neural networks. 1989, another guy, one of these guys, Jan LeCun, he presents the convolutional neural network. The convolutional neural network basically was an implementation of a prior model called the neurocognitron from the late 70s. Basically, it's the same model, but Jan LeCun actually managed to show that the convolutional neural network can be trained using the backpropagation from 1986. So combine backprop with the concept of the neurocognitron, we get the convolutional neural networks. And in 88, 89, he manages to get the first application of a convolutional neural network to recognize handwritten digits. That's probably the first successful application of neural networks. In the 90s, this system is used by the postal system in USA to recognize addresses in letters, right? To recognize the digits in the letters, and also by ATMs to recognize checks, digits in checks. This is the early 90s, late 80s. Also, one of the contributions from this time is that the MNIST dataset, which is that dataset of handwritten digits that has become the staple, and that's the hello world of neural networks. That was a contribution from this time as well. Contributions like the RNNs, recurrent neural networks, and LSTMs, also from the paper of LSTM come in 1997. And I think a couple of years later, basically the same LSTM that was used by Google in 2016 to do the translator machine, the neural translator, basically the same model. So 30 years before. So there are really important contributions, but there was not still like data and still computer power, enough computer power to actually take advantage of this. So there is this kind of the second winter, which is the 90s probably. There is not a lot of research in artificial intelligence. The expert systems were kind of out of fashion. So people say, okay, we want to research about this because this is interesting, but government doesn't want us to give us money. Government don't want to give us money to do artificial intelligence. So what do? Someone comes with the idea, okay, I'm not doing AI. I mean, AI, yeah, that's from the 60s, these crazy people that thought that they could do this kind of AI. What I'm doing is allowing machines to learn. What I'm doing is machine learning. So in the 90s, the term machine learning appears, which is basically people saying, I'm not doing AI, I'm doing machine learning, give me money. It's not the same. So machine learning concepts appear in the 90s, like support vector machine, random forest comes in the 90s, if I'm not wrong, and different tree-based algorithms from the 80s and 90s. And then the 2000s come, I mean, this century comes, and then it starts like little by little, people start showing that neural networks are not too bad. I mean, it's still working. Not many people working in neural networks. But still, these people from the 70s and 80s, the ones that did the backprop algorithm, the ones that presented the CNN, the LSTM, they were still working in neural networks. So in 2006, there comes I think it's the year when the term deep learning appears. That's by Geoffrey Hinton, who is working in the same guy of the backprop algorithm, who is working in restricted Boltzmann machines, which is a kind of neural network. And then we have some, I would say, really, really important milestones, 2009 and 12, ImageNet and AlexNet. We're going to talk about that next. Okay, this is what I was telling you, like SVMs in the 90s, decision trees in the 80s, random forests in the 90s, neural networks and backprop, kind of in the 90s. Again, there are still a little bit more people working on this. And yeah, okay, machine learning is a concept from the 90s. And then we have the 2000s, when deep learning appears, and then we start working or talking about neural networks again. So, but I mentioned before, 2009, and I would say this is a really iconic, a really important milestone. I mean, something that we should be aware of, like I don't know, 1972, the fast Fourier transform was invented. 2009, the ImageNet. By the way, I would argue that the fast Fourier transform is the most important algorithm of the last century. So that's why I know, well, 1972. I would say the invention, the creation of the ImageNet dataset is really important. And basically is this, and I like to say it because I think it's relevant. It was 2008. People were working in, if you read papers from that time, related to computer vision, you will see that people were working in datasets that were probably a few thousand images. with a few hundred classes or categories in images, like cats, dogs, cars, whatever. So, and the problems were like, okay, how can we extract the information, kind of an expert system? How can we transform the data in the images so that we can apply some support vector machine algorithm to classify the images, right? So that we can recognize finally, successfully, what's the difference between an algorithm, so that we can classify between a dog and a cat. And so, okay, and I repeat, if you read papers from that time, you will see that there's a lot of, the concept of descriptors is quite important, which is basically probably the most useful tool for descriptors was creating histograms in the images. And histograms were not only colors and intensities, there were histograms of gradients, histograms of whatever characteristic you can find in an image. You would create histograms, you would concatenate the histograms, and then in the end, you would apply something like support vector machine, and then you would have some classifier. That was about the first 10 years of this century. Okay. 2009, Fei Li, who is the main researcher, she is one of the most influential AI researchers alive, I would say. I mean, she's really a really remarkable person. So she visualizes, she realizes that data is really important. Variety in the data is really important to train models. And so she decides that in order to train models, we need this kind of more varied data. And so at a very important point in her career, because she was starting as a faculty member in Stanford, she was like, okay, I need to get my tenure, but I think data is really important. And this is a characteristic of people who has done really important contributions in AI. She realized the importance of data. And so against the advice of many clever people that she respected a lot, she decided, I'm going to build a data set. And so she starts the quest of building the largest natural image data set available up to that point, which is ImageNet. So this is about 14 million images, all of them classified, annotated. The annotations were like, okay, we have an image of a dog, let's say it's a dog. An image of a cat, let's say it's a cat. But still, I mean, we are talking about 2009, so annotations had to be done by a human. So you had to annotate 14 million images and also collect the 14 million images from the internet. So it was a massive amount of work. I mean, Fei Li has said that in interviews that she thought it was going to be something that she would pay some TAs to do the annotations and say, okay, we pay some TAs and then it's gonna be relatively simple to do, but it was impossible. So this is one of the most successful applications of Amazon Turk because all the annotations were done by Amazon Turk. So people, I don't know, in different countries were doing the annotations. They got the data set. Okay. So finally, we have a data set that is massive and it has 20,000 classes. So this is 20,000 different kind of images, dogs, cats, sheep. Well, actually, about 200 breeds of dogs, about 150 breeds of cats, and well, and different objects, right? 20,000 classes. So the dataset is launched. And then, okay, we have the dataset. What do we do? And in 2010, Fei Li and her group, they launched the competition called the ImageNet, well, the ImageNet Large Scale Visual Recognition Challenge, this here. So it was presented in a conference, one of the most important conferences in computer vision, probably the second most important conference in computer vision, which is ICCV, the International Conference in Computer Vision. I think it was in Italy back then. No, I don't remember the place. Still, 2010, they launched the competition, and it was like a workshop. So researchers from all over the world who are doing computer vision would come and present their algorithms and see how they do. The competition was an extract of 1 million images with only 1,000 categories of the of the 20,000 possible categories and 14 million images, it was, the competition was, okay, categorize well 1 million images with 1,000 categories, right? So that happened, there was a result. 2011, again, there's a result. Okay, yeah, we are talking about, but back then it was like high 20s. The error achieved by the algorithms were in the high 20s, like 28% error, just to say a number, high 20s. 2012 arrives, and actually in an interview, Fei Li mentions that she was in maternity leave. She had just had her baby. And they launched the competition. She didn't go to the competition or to the conference because of her maternity leave. And she says that in the middle of the night, that was the one that was in Italy, she receives a call that says, you have to see this, right? And they show her that the winning model shows a 15% error. And that's kind of chilling. I mean, that's really impressive, because the second place was getting like 25% error, the second place. And then the first place was getting 15% error. That's a massive difference. I mean, the difference between the second and the third place was like 2 or 3%. The difference between the first places in the previous 2 iterations of the competition was about like 1, 2%, and in the high 20s. Now, having something that is 10% is really significant. I mean, means there is something different. I mean, there is not only people doing some sort of descriptor and then doing a SVM algorithm on top of the descriptors. It's something different. And so what's the model? And the model is, it's a CNN. It's a convolutional neural network. And the story goes like, a CNN? Isn't that old model that people were doing in the 80s? Yeah, that model. So basically the same model that people were doing in the 80s to recognize handwritten digits. And this is literally basically the same model was trained now with this kind of data and achieved something that was, at that moment, was remarkable. And that's the AlexNet moment. It's called AlexNet. Let me probably, I will show an image. Let me show this image first. So we are talking that in 2010, the first time of the competition, the error was 28%. 2011, it was 25%. And then 2012, the year of AlexNet, it was 16.4%. Okay, what does this mean? And what is AlexNet? So as you probably already know or have guessed from what I said, AlexNet is the name of the neural network that won the competition in 2012. It's called AlexNet because it was the first author is Alex Krzyzewski. The second author of that paper is a guy called Ilya Suskiva. And the third author of that paper is Geoffrey Hinton. Geoffrey Hinton, the guy that did the backpropagation algorithm, this guy in the 80s, 1986, he presented the backprop algorithm for neural networks. That guy is now an older guy. He has a group he has been working for neural networks for 40 years already. Yeah, 40 years already working on neural networks. He has a master's student called Alex Krzyzewski. He has a PhD student, a really clever guy. One of the, I would say, the most famous, most important younger guys in AI, Ilya Suskiva, which you might have heard. Does anyone know who Ilya Suskiva is or why he's famous for, apart from AlexNet?
He left Google and he went to OpenAI, right?
He founded OpenAI.
Yeah.
He's the founder of, one of the founders of OpenAI.
But as I understand, he was in Google before.
He was in Google after this. After this, and we are going to mention this. Yeah, he was in Google, indeed. He was in Google after the ImageNet moment. And this is interesting because, okay, so the story goes, and this is an interview by Geoffrey Hinton. He says, okay, so I have this Ilya Suskiva. I mean, by then, Geoffrey Hinton, Ilya Suskiva was his PhD student. He was aware that he was a genius. I mean, he said that the first time he interacted with Ilya Suskiva was when he was an undergrad student, that he was like 17 and he wanted to work on neural networks. And the first thing he said is that Ilya came to his office, asked him, I want to learn neural networks. He gave him a paper, the paper of 1986 on backpropagation. And he comes back the next day and Ilya says, this doesn't make sense. And Geoffrey Hinton is like, well, it's only calculus, right? It makes sense. And he said, no, that makes sense. And he comes with, Geoffrey Hinton says that Ilya comes with several flaws of the paper. like that the author, they didn't realize at the moment, right? So, okay, the story goes that Ilya Sutskever says, we can win the AlexNet, the ImageNet competition if we train convolutional neural networks on GPUs. And then that's another milestone. In 2006, NVIDIA releases CUDA. And that allows the community, the scientific community, to use these graphics cards that were reserved for doing only graphics, like video games. They released the framework that allows using graphic cards for general purpose computing. Back then, there was the term GPU. Nobody uses it now. But back then, I mean, we are talking about 2010, 29, 2009, 08. I mean, people were talking about, okay, if you want to do parallel computing, you have threads in a microprocessor. We have GPUs, which were general purpose GPUs, which is GPUs. And then you have FPGAs, for instance, which is what I did for my PhD. That's another story. So GPUs, so that becomes a thing in 2006. So Ilya Sutskever comes with the idea, and he says, we need someone who is really good at programming. And the story goes that Alex Krzyzewski is a really extraordinary coder who was capable of implementing all the convolutional neural network in 2 GPUs using CUDA. And we are talking about, this is not Python, this is actually doing it in C++, and implementing the backpropagation algorithm for a convolutional neural network is not trivial. It's kind of, it's interesting. And he had to split all the data into GPUs. Well, he did it. Also, he said that, Geoffrey Hinton says that all the training of the models were paid by Alex Krzyzewski's parents, because he was still living with his parents and he trained the models in his house for 2 weeks. So the models are trained, they go to the competition, they won the competition. This is 2012. This is the model here, the one that I'm showing here. And then kind of the rest is history, but it's a very interesting history. Still, so all the models that follow are based on convolutional neural networks. Up to 2015, when it is for the first time, the error is smaller to what we believe, or the community believes, a human would do. And so it's the first time that 5%, which is the estimation for a human, the estimated error for a human, is passed. I mean, we get an error, or there is an error that is smaller than 5%. And that's when the competition kind of stops. You can still find it or find the data set in Kaggle, but it was like, okay, this kind of problem is solved, but still all convolutional neural networks. I mean, from 2012 to 2015, these are like famous models. Like in 2015, the ResNet, we are going to study that model in detail because it's a really important model, is presented, and then it achieves a result that is better than a human. How do we know that it's better than a human, or how do people know that it's better than a human? Because another very famous guy, Andrew Karpathy, who was a PhD student in the Peifei Li group, he worked a lot in the ImageNet and collection. He has a very famous, one of the first deep learning courses online. Is from him in 2015. He's the one teaching it. But still, I mean, he became very famous in 2015, 2014. Yeah, something like, no, probably prior that, probably more like 2012. He became very famous because he is the only human known that did the ImageNet challenge by himself. What does that mean? That he classified by hand 1 million images. Like, you would present to the models and classify these 1 million images with 1,000 classes. He did it by hand. And he achieved about 5% error, and that's the human metric we have. So that's why it is thought that, okay, less than 5% is better than a human. So that's the story. But still, 2012 was a very important year because of AlexNet. And companies like Google realized that, okay, this is something. this is something, and this is how Ilya Sutskever and Alex Krzyzewski come to Google. So Google says, okay, you guys, Geoffrey Hinton, Ilya Sutskever, Alex Krzyzewski, come to work with us. I mean, we will pay you very nicely, and you come to work with us in these neural networks that maybe have some future, right? We kind of think that they might be interesting. So let's work on them. You work on them. By then, the Google Brain research team was already created. The Google Brain was like the first artificial intelligence group in Google, and that was founded by Andrew Ng, the founder of Coursera. I'm pretty sure that you have heard of him. So that was in back then. So, and Geoffrey Hinton very cleverly says, okay, this is Geoffrey Hinton, by the way, in case you didn't know him. He says, oh, okay, yeah, we probably, there's interest. So instead of you only hiring us, he founded a company called DNN Research, which had only 3 employees: Geoffrey Hinton, Ilya Sutskever, and Alex Krzyzewski. So they founded the company. They didn't have any product. They didn't have anything. They just founded a company. I think you can do that fairly easily in Canada. So they founded the company, and you say, Google, if you want us to work for you, buy the company, because we are already hired by this company. And so he sets an auction for the company. And so the auction is between Google, Microsoft, and Baidu. And so they have a night when they are receiving the offers by the companies. And I think the official fee is not disclosed. Geoffrey Hinton has said that when they were achieving like $43 million, by then Microsoft had already pulled out of the competition because Microsoft didn't see much future in neural networks. So he said, okay, I'm not going to be paying $40 million for this thing. And so the competition was between Baidu and Google. And Geoffrey Hinton said that when they were, this thought that it was like $43 million, and Google was winning, he said, I was not totally convinced of what Baidu was doing in China. So he said he closed the bidding and sold the company to Google. And so the company was sold to Google it is thought that $40-something million. If indeed was $40-something million, it is agreed that this one is one of the greatest steals in history. I mean, like Google paid really little money for the company, but still they got their $40 million. They said that Geoff Hinton kept 40% of the money, and then Alex Krzyzewski and Ilya Sutskever kept 30 and 30%. Right? So 40, 30, 30 was split, and that's it. So they sold the company, and on top of that, they went to work for Google. They were hired as interns. Geoffrey Hinton became the oldest intern in Google. Back then, he was already like late 60s, probably early 70s. Yeah, late 60s, probably. And so that's it. That's the story, and that's how they got to Google. And they were Ilya Sutskever, Alex Krzyzewski worked on the development of TensorFlow, and they were part of the Google Brain team up to the point when Ilya Sutskever went to create OpenAI, and then Alex Krzyzewski, I think, got tired of neural networks and decided to be rich and live from his profits. So these are the guys. This is Geoffrey Hinton, Ilya Sutskever, and Alex Krzyzewski in the back. So I find it really, really interesting. And so probably that's agreed. I mean, as the moment when that kickstarts the deep learning revolution we are living right now. So all the way from the artificial neuron, the perceptron, all the way till AlexNet. And then since then, I mean, it's been like a real, I mean, when I started teaching deep learning, like in 2019, 2020, it was like, okay, AlphaGo, that's really important. I mean, if you haven't seen the documentary of AlphaGo, please watch it. It's amazing. It's free in YouTube. But yeah, AlphaGo was a really important milestone. And then probably more importantly, we have the first version of AlphaFold. Does anyone know what AlphaFold is?
Nope.
Yeah, someone wrote here, well, it's not AlphaFold, but Geoffrey Hinton, and this is interesting because Geoffrey Hinton, Jan LeCun, and Joshua Bengio, they won the Turing Award in 2018. So that's the most important award in computer science, called the Nobel Prize for Computer Science. So they were recognized. I mean, Geoffrey Hinton says that because he has been asked many times what motivated him to keep working in something. He mentions that going to a conference in neural networks was like probably 10 people attending the talk. In that, we are talking about the 90s. And many clever people, he says, that told him, stop wasting your time working on this. And it was only after 35 years that he was vindicated, right? And he's one of the most famous personalities in AI. And indeed, he won the Nobel Prize last year, in physics. So yeah, which I find remarkable, because his answer is that to what did he think when people were telling him that's not worth pursuing, was like, how can people be so stupid, being so smart, be so stupid at the same time, and not realize that this is the way to do it. And still, I mean, took a long time, but wow, still. So AlphaFold is the model by DeepMind as well. I mean, DeepMind back then had already been bought by Google, but they were still like independent. In 2023, they were totally merged. But DeepMind, okay, they did AlphaGo. Prior to AlphaGo, they had very important results. AlphaGo was probably the first one that was really famous. And AlphaFold, I would say that the first version was not so famous. But it's the problem that from a sequence of amino acids, you predict the structure of the protein. I'm not an expert in biology, so that's what I understand from the problem. And I understand that the combinations are like massive. And I also understand that predicting the 3D structure of the protein from the amino acid sequence was kind of a PhD kind of problem. It would take humans 3-4 years to complete. So they presented a model in 2018, the first version of AlphaFold, that was capable of doing this with a very high accuracy. Then AlphaFold 2 came in 2020. And that was a model that won the competition for 3D protein prediction, beating the competition is called the CASP competition. And it was a massive result, right? Okay, that is if you have heard the other Nobel Prize in this year that is related to AI was the Nobel Prize in chemistry. And one of the winners, one of the recipients was Demis Hassabis. Demis Hassabis is the founder of DeepMind because of this model. Because now this model has been used by chemists to predict, I think, all the known proteins and even proteins that didn't exist before. I don't really understand the chemistry part of that. So it was won by Demis Hassabis and two other people who actually made the 3D structures for proteins using AlphaFold. So that's kind of remarkable. I'm going to skip this. I mean, there are some other models like mu0 from also DeepMind. BERT is a really important model. We're going to read the paper. And then we have the GPT models, right? The first GPT came in 2018, then 2019, GPT-2, then 2020, GPT-3. And back then we could still listen to people saying, okay, by GPT-12, do you think GPT is going to be useful to solve AI? And it was like, maybe, I don't know. But it was like, okay, not many people in 2020, even when GPT was in its third version, and we were talking about something that was in the billions of parameters, not very many people knew about GPT or were using GPT, right? GPT-4, GPT 3.5 was ChatGPT. That's the model that probably put the GPTs in the scenario and everybody got to know it. DALL-E was one of the first models that actually was generating these very pretty pictures from a prompt input. Yeah. Well, some other researchers, Tesla with autopilot, they have very nice efforts in solving autonomous driving. There are other efforts by Waymo and now other companies. And Neuralink, also really interesting efforts trying to integrate AI already inside the brain. Really cool, interesting stuff. And yeah, kind of that's the way we get to this point. I mean, like really quickly, and I find it really, really amazing how we came through so fast. So up to this point, is there any question? Cool. So just to end the lecture today, just like, okay, so we got like, there's this story and we got to the point we are now, right? And so you will probably hear or see somewhere the term GOFAI. That's good old-fashioned artificial intelligence. That's the kind of expert systems AI. That's the kind of models based on rules and this kind of models. Some like there will be like search algorithms that also are classified usually between inside the scope of AI. If you have seen like breadth, depth, first search, A-star search, they're considered like AI. They fall within the good old-fashioned AI. But within that, all this universe of AI, I mean, one subset would be machine learning. And within machine learning, we will have deep learning. Because it used to be the case that neural networks were taught as a model inside machine learning. And they were taught differently than they are taught today. Because they were not so deep. We are talking about, okay, 3-4 layers maybe. Not many. Now we're talking about some models are in the thousands of layers. So yeah, just to put it in context, we are going to be working just in this little bit subset that is called deep learning. Right? Within this small subset of all the artificial intelligence universe. Right? So that's what we are going to be doing. And the next thing we are going to be doing is, okay, just to mention this, just to put in context what we are going to be doing. We are not going to be using that much of machine learning, except for the fact that neural networks are a part of machine learning. But in general, machine learning models tend to be like, that are like in this subset. They tend to be very heavily on pre-processing the data. And then we have a lot of machine learning feature extraction and feature engineering that we transform the inputs into the features into something different. That's machine learning, like in the general context. We are going to be using deep learning. And one of the advantages of deep learning is that it tends to be end-to-end. So it's like we input the data as images and we get the results, whatever we want the result to be, like classes. And we are going to be focusing in the context of supervised learning, which is data that has been previously labeled and classified. This is something you have seen already in your machine learning courses. So that's what we're going to be doing. Neural networks, supervised learning, and trying to cover very briefly everything from neural networks all the way till transformers, and then we will read some papers related to LLMs. And last week is going to be diffusion, which is this generative model that generates pretty pictures of dogs wearing astronaut suits. Okay, so I think this is gonna be the point where I'm gonna stop. There are some other slides, but that's going to be covered in the tutorials for the week. So I'm not gonna spend more time on that. I don't know if there's any question or anything you would like to comment.
Just a question, Professor.
Yes,
How often are we gonna meet in live class, in active
once a week.
class? Once a
Okay,
week.
yeah, we are gonna meet weekly. As I said at the beginning, the sessions are optional. They are going to be recorded in case you cannot attend. But still, we are gonna be meeting once a week. Most of the sessions are going to be like office hours so that we can comment on questions you may have about the homework, questions about you may have about anything, many things. Sometimes people come with papers that they've read and I have no idea. So it's gonna be super cool, yeah, just to share whatever you are doing related to deep learning. Except for week 6 that we are not gonna meet. then we are going to be meeting every week.
Okay, thank you very much. I really enjoyed this.
Thank you.
Excuse me, Professor, one question. Is it possible to have the classes at 6 p.m. instead of 5:30 or?
Let me check with the analysis, but I would say it's not an issue.
Just because I believe almost that everyone that works goes out.
Yeah, I understand that. I understand that. I don't think there is an issue. I don't know. Is it possible that, let's say, there is no problem with me?
Yeah, it's possible to have it at 6.
I think we can have them 6 to 7:30, more or less. Yeah, something like that. Yeah, no problem. The other
Thank
thing
you,
I
thank you.
mentioned is that we will post an announcement for the next session, because I think I'm gonna be traveling next week. So on Thursday, I'm gonna be coming back to flying back. I'm based in Querétaro, Mexico. So I'm gonna be flying back to Querétaro. So I will be arriving like at 6. So maybe we have to shift it next week to 8 p.m. or to Friday. We will advise on that. We will let you know that on
Thank you.
Monday. Yeah, any changes that are due to traveling or something, because sometimes I mean, we'll let you know, right? Anything if by any, we'll let you know early enough. I mean on Monday, you know, if we are shifting it to Friday or we are delaying it. Or...
Another question, Professor. For this class, are you gonna need like a super professional version of Colab or a super big APU or how you know?
No. I mean, everything we are going to do is like the most intensive training we are going to do is the translator, and still we are not going to be evaluating on the you are not going to beat ChatGPT or Google Translate or anything. The idea is just to understand the principles. So it's going to be a poor translator, but still, that's probably the most complex. And then training in Colab for 30 minutes is going to be okay. Gonna be enough.
Thank you, Professor.
So everything is going to be like enough with Colab. Still, there are some other platforms that I think are better than Colab that are free as well. So you might want to have a look at. There is Lightning AI. I think that's a good platform. They do have like they are paid, but they give you like a few hours of GPU that are quite good. Kaggle also is a good platform for GPUs. Someone is mentioning DeepNote. I didn't know about that one. So yeah.
Okay, thank you.
Yeah, platforms like Weight and Biases are really good. RoboFlow also for computer vision, really cool as well.
Excuse me, Professor.
Yes.
Is enough to try to work with Google Colab free version, or we need to buy a version Pro or something more?
No, it will be, everything is simple enough.
All right.
In terms of compute. So the free version of Colab is going to be enough.
All right. Thank you so much.
So that's gonna be enough. Yeah. I mean, the idea is that since we are going to be implementing like foundational, like really things that fundamentals, we are not going to be training the next version of ChatGPT. I mean, no, it's not the aim of the class. The aim of the class is understanding what's behind these models. So even if our training leads to some really poorly performing model, the principle is to understand the principle behind. The idea is to understand the principle behind, not have the most high performing model. Yeah. So Colab is good enough. If you have like some local GPU, that also works. I mean, many people has done it. People have trained also. I haven't done that, but some people have trained locally on Macs with the M processors, and it seems to work fine as well. So but yeah, if you don't have a GPU, a local GPU, Colab is going to be enough. The free version of Colab. And also, as I said, like Lightning AI or DeepNote that someone mentioned, I haven't used it. Kaggle has a very good platform for GPUs, and you get like 30 hours a month, I think. Also, I think the Amazon SageMaker Studio, I think also offers you like 4 hours a week. of GPU, something like that. So that is plenty for our purposes. Those are alternative. Otherwise, Colab is really good. It's good enough, at least for this one. It's not really good, but it's good enough. So next week we are going to be the homeworks are going to be open every Tuesday. The activities that you have to. So every activity we are going to be opening the activity, and you will have 2 weeks to complete the activity. So it's going to be from Tuesday till Monday midnight. Not the next week, but 2 weeks after. So Tuesdays. So, and we are going to have 5 activities, if I'm not wrong. So you will have like, there will be activity 1 week yes, 1 week no, right? Weeks. So someone is asking, many of the activities are going to be, you are going to be provided with the code and the activities understanding the code. So there are tutorial videos that might help you understanding. So one of the things that you're going to be graded on when you are given code is to comment the code very carefully. Like do a proper docstring. If there is a function, try to do do a docstring that specify what the inputs of the functions are and what the function is doing. So those comments are preferred in English, right? So the idea is that we do it in English. If for any reason you don't want to do it in English and prefer to do them in Spanish, just let us know. Let us know so that we inform the grader, whoever is grading you, that the comments are going to be, that this team has asked to have the comment in Spanish for whatever reason, that's fine, so that we can let know the grader that if the comments are in Spanish, it's okay. So that you are not like penalized because the comments are not in English. Okay? But just let us know if you want to do them in Spanish, otherwise do them in English. Why in English? Because it's way easier to share. If you want to share that on GitHub or anything, you will have a way, way wider scope to, you will reach more people if your comments are in English. That's the idea. Any other question, comment? So, super. So thank you very much, everyone, for showing up. We'll see you next week. And if there's any question, just please send us an email and we'll try to answer as soon as we can. Right? Thank you so much.
Thank you. Thank you
Thank you very much.
Bye.
You guys.